Hi everyone. I am anticipating that tomorrow we may run into trouble with weather and that team could possibly be delayed at the very least. And so I am going to go ahead and do videos for lesson 6-2. We will also be including parts of 6-3. I think that it would not be in your best interest for me to try to teach this, especially if we have a condensed class tomorrow. So I'm just going ahead and doing this video, and then I will have it ready to send to you tomorrow. We are going to be looking at 6-2, which is properties of parallelograms. So we are on page 391 in the book, and I will also be including part of 6-3, which is a lot of converses to what we're going to be doing today. So Friday's homework will incorporate questions from both lessons. All right, so this is video 1 for lesson 6-2, and let's start by reading the paragraph just to the left of the race car. Any polygon with 4 sides is a quadrilateral. Now, we studied quadrilaterals Tuesday in class as being a 4-sided polygon. Some quadrilaterals, however, have special properties. These special quadrilaterals are given their own names. We're going to be looking at parallelograms. A quadrilateral with 2 pairs of parallel sides is called a parallelogram. Sorry, I'm not doing a very good job of holding the phone and teaching. To write the name of a parallelogram, you use the symbol that I call a crooked rectangle or a tilted rectangle. So if you'll look at parallelogram ABCD right here, you'll notice that we can either write out parallelogram ABCD or we can draw the symbol for parallelogram ABCD. But either way, what you need to notice is this name is built on the fact that this quadrilateral has 2 sets. Here's one set, A, B, and C, D, of parallel sides, and here's the other set, B, C, and AD, of parallel lines. So we have 2 sets of parallel lines. That is what it takes to make a parallelogram. All right, we're going to look at other properties of a parallelogram, and we're going to be looking at the converses of them that come from lesson 6-3. So if you'll look at theorem 6-2-1 with me, if a quadrilateral is a parallelogram, then its opposite sides are not only parallel, but they are also congruent. Let's look at our figure. Here we show that they are both parallel, and by coloring them each a different color, these 2 are red, they're showing you that AB is congruent to CD, and using the blue, they're showing you that BC is congruent to AD. So we have BA and CD not only parallel, as their name parallelogram tells us, but we also have them congruent. We also have BC and AD parallel and congruent. All right, let me flip the page. We're going to jump to page 399. So if you would do that with me in your book, it's actually 398 where this converse is. And let's see. If you will look at 6-3-2 with me, we will come back to 6-3-1. But again, these are conditions for parallelograms. In other words, it's required for it to be a parallelogram. And this is simply the converse of what we just learned. So this time we're saying it in the opposite order. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is in fact a parallelogram. Okay, jumping back to 6-2, we're going to be doing a lot of that. I am going to do a quick review with you of a proof, but I'm going to start a new video with that proof. So I will end video 1 and be right back with video 2.